So I'm sure at this point in your math learning career, you've heard about infinity. And today we're going to be learning about infinite series. So infinity might not seem real at first because we don't really see it in real life. But in reality, you can just replicate infinity right now. Let's say you were to take a ball and you were to throw it. And it bounces on the ground. And we're just on Earth, we're not on Moon, we're not in space, none of that stuff. Now it's going to come here and it's going to bounce up. And it's going to come down. And it's going to bounce up again. And each bounce is less than the previous one. And it's going to keep bouncing. Until at one point it stops. But let's just say it never stops. And we can always measure the amount of distance it bounces. So it's going to keep going like that. Now, we're asked the question. How much total distance does this ball travel? And that's going to be very hard to figure out if we don't grasp at the idea of a divergent series and a convergent series first. Trust me, this has something to do with infinite series, and we'll figure this question out soon enough. So we have to understand what these are. Now, a divergent series is basically a series that either approaches negative infinity or it approaches positive infinity. Or just bounces in between as the number of terms goes up. Like it can be very negative at one point and then more positive and then more negative and then more positive and keep going. It's going to keep oscillating back and forth. And then a convergent series is a series that approaches a finite number. For example, the ball that was bouncing. Each bounce is less than the previous one. It's going to be looking like this. Now, if we take this point right here in time, of course, it's going to keep bouncing, but the incrementing amount is going to be less and less and less, and it's going to approach a certain number, which is the total distance it bounces. Now, this isn't very accurate. It's just going to be a rough estimate. It's not going to be very accurate. It's going to approach that number, but we can never figure out the total distance that it travels because it's infinite. That's just not possible to figure out, but we can figure out what it approaches. This is all really unreal. But you'll grasp it soon enough. So now our job is to classify an arithmetic infinite series into whether it's divergent or convergent. This should be easy to do because there's a common difference. For example, 2, 4, 6, 8, and we add them up, and it just keeps going. Is this convergent or divergent? Well, we can see that it's clearly not approaching any finite number because it's going to keep adding. Like the next term will be 10, and then 12, and it doesn't seem to be approaching any finite number at infinite terms. So this is just approaching positive infinity. And now if we take another one, for example, 5, 3, 1, -1, -3. Now at first glance, this seems kind of confusing. We have positive numbers, we have negative numbers. What are we supposed to think? Well, we can see that positive numbers, there's no more positive numbers higher than 5. 5 is the first term. But it keeps going down by 2 for every term. So this is going to approach negative infinity as it reaches infinite terms. So does that mean that all arithmetic series are divergent because they either approach positive infinity or negative infinity? Well, no, there's two special cases. The first special case is when, well, actually both of them have d being 0. The first one is when a1 is 0 and d is 0. And it'll just be 0 plus 0 plus 0 plus 0. This is the only convergent arithmetic series you will ever see because infinite zeros is still 0. It doesn't matter how many zeros there are. There can be infinite zeros in here. It doesn't matter because all the zeros add up to still be 0. Now we're going to look at the second type. This is when a1 is not equal to 0, but instead equal to any random number that is non-zero. Now the whole thing will just still approach positive infinity. So I guess it's not that special. So something like this maybe. But it is still worth noting because d in this case is 0, and it's sometimes messes with your brain when you see it.